All right, so let's talk about the probability that these errors occur. The probability of a type 1 and type 2 error. Significance tests are designed to control a type 1 error, which is because the tests are designed so that as that being the more serious mistake. So we can control type 1 error very easily. The probability of a type 1 error is simply the significance level. Remember the alpha level that we were picking before? Oftentimes we pick 0.05. As long as you pick that before the test, the probability that you make that mistake, that you make a type 1 error, is going to be 5%. It's a probability that you reject the hull, given the hull is true. So the probability of a type 2 error is called beta. This is a bit difficult to calculate. It depends upon a lot of different things, and we'll kind of talk about that a little bit later. The significance level is related to the confidence level. I'm kind of introducing confidence level here, kind of trying to link it to confidence intervals a little bit. That may or may not be a wise choice, but I'm going to do it anyway, whatever. So the confidence level is a probability that if the null is true, you correctly do not reject it. So if you reject it 5% of the time incorrectly, then 95% of the time you're going to make the right decision. And then power, and this is kind of a big topic that we are going to dig into later. Power is a probability that you correctly reject a false hypothesis. So given the null is false, what's the probability you reject it? And that's going to be linked to the type 2 error. Given the null is false, the probability you fail to reject it is beta. The probability you correctly reject it is going to be the complement 1 minus beta. So let's just say this was like 25%. Then this would be 75%. So the null is false. What's the probability you fail to reject it? 25%. What's the probability that you properly reject it? 75%. Faster fast food. A manager at a fast food restaurant wants to reduce the proportion of drive-through customers who have to wait longer than 2 minutes to receive food after their order is placed. Based on store records, the proportion of customers that had to wait longer than 2 minutes was 63%. Okay. To reduce this proportion, the manager assigns an additional employee to assist with the drive-through order. So they hire another employee. During the next month, the manager will collect a random sample of 250 drive-through times and test the following hypotheses at a significance level of 0.10. Not sure why he picked 0.10, but whatever. His prerogative. Power of the test is 60%. So P is the true proportion of drive-through customers that have to wait longer than 2 minutes to receive their food. And then my null is that it's the same, that it hasn't changed, against the alternate that it's now lower. And he's kind of hoping that it's lower. He's hoping this extra employee helped. Describe a type 1 error in this setting. So always remember, O is true. So the percentage is still 63%, but we incorrectly think it's less. So we conclude, or I should maybe say he concludes, the proportion that weight is less than 63%, when in reality it is still 63%. So it hasn't. We're going to conclude that it's been lowered because of the new employee when it really hasn't. Explain the consequences. Well, we think the problem is solved. It's fixed or is better, but it's not. And we probably will continue paying this employee, even though that employee is not helping. So these are kind of bad, right? I mean, we're wasting money on an employee that's not effective. I mean, it's not the employee's fault, but like the hiring an extra employee didn't change things. We're not necessarily blaming the employee. And also, we think the problem's fixed, but it's not. So we're not going to try to find other solutions because we think it's fixed. Type 2 error. So this is going to be the null is false. So this is where we're going to say, well, the percentage is not 63%, so it's actually gone down, but we fail to detect it. So we conclude, we do not conclude the proportion is less than 63%, when in reality, it is less than 63%. So consequences of this error. Well, obviously, I kind of think this is we lose an opportunity. Well, kind of opportunity lost, I guess, is what I'm trying to say here, right? If I'm spelling that right. If I'm not, I apologize. We think the new employee didn't fix the problem when he actually did. So, however, we'll probably keep looking for solutions because we still know the problem exists. It's just hiring this extra employee helped, and we kind of don't know it. So opportunity lost, but I think the key point is we still know that there's a problem. So we're going to look for other solutions, maybe even better solutions. Which one's more serious? Type 1 error. Why? Problem still exists, and we don't know it. Also waste of money and stuff, but whatever. Calculate the probability of committing a type 1 error. That's our alpha value. Type 1 error is the alpha value. Probability of committing a type 2 error. That is the complement of the power. That's it.